we want to draw our shear force diagram. Okay, so now we've got this. So basically we want to draw this kind of grid to show that at these points there's a potential that something important, or there could be a maximum or a change could happen. So the first things first, we'll draw our shear force diagram, and there's our bending moment diagram. So looking at our shear force diagram, we know that the shear force at point A, due to the reaction that we calculated, will be 12 kilonewton, or 12 kips, right? Now, since we have a uniform distributed load of the first, or of no degree, so we have a constant uniform distributed load, we know that the shear force diagram will be one order higher than the uniform distributed load. So one order higher than the uniform distributed load is going to be a straight line. Basically, we're going to have a straight line going from A all the way to C, and we're going to have a minimum value at point C. What we can do is we can find the equation of that line by taking a section and summing the forces. So if we took a section, say here for example, that's section 1. We've got our 12 shear force, an arbitrary direction. I'm just going to do counterclockwise because it's positive for our moment at that section. Now we've got our distributed load, 2 kip per foot. So to get our shear force equation, we want to sum forces in the y equal to 0. So we've got 0 equals plus 12 minus our shear force at some distance x away from point A. And then because we have a distance, an undefined distance of variable x from point A, our uniform distributed load will be 2 times x. And that's going to be the total downward force, the area underneath the UDL. So now we can see that our shear force equation, V of x, is just equal to 12 minus 2x. So now since we're interested in the shear force at B and then the shear force at C, we can plug in the x distance from A to calculate those. So we want to find the shear force at C, which is 24 feet away from our point A. So if we draw our straight line, so we have positive shear force, negative shear force, and another negative shear force. Now we know that the support reaction at C was equal to 72. So, and it's going in the positive up direction. So if we're at minus 36 right now, going from left to right, then we need to bump it up 72, and we'll get to a positive 36. And then we know that we're still at a UDL, so we can just connect the dots, and there's nothing in between, no important points in between, so it'll just be a straight line all the way back down to 0. And we have a positive force. Now let's draw the bending moment diagram. We look at the shear force diagram and we know that we have a 0 shear. So the significance about the 0 shear is that that point is always going to give us the critical point, maximum or minimum, for the moment diagram. So because we know that the derivative of the moment equation is going to be the shear force equation, and setting that equal to 0 will give us a maximum or minimum, so this point will give us a maximum moment. So there's a couple ways that we could do this. We could either take consecutive sections and find the moment equation and then plug in our values for our distances and calculate our maximum moments, or we can always just look at our shear force diagram that we've already calculated, and we can just calculate the area under the curve to get our maximum, or to get our values at our moment equation. So we know that because the zero shear provides us a critical point, we need to find out if that's going to be our maximum negative or maximum positive moment. So what we need to do is calculate the area under the curve from our point A to the halfway point from B, or at the zero shear. So and then we know that this is positive because it's positive 12 times a distance 6, which has no positive or negative in this context. So we know that this is going to be positive 36, and that is our maximum moment. So now to solve the bending moment diagram, we need to find out what the moment is at support reaction A. So now we want to calculate the support reaction for our moment at point A in order to complete this first part of our bending moment diagram. So sum of the moment at A equals 0, saying 0 equals 72 clockwise, so it's plus 72. Remember, it is, this distance is 12 feet at the hinge, 12 feet, 12 feet, so 24. Now 12 is clockwise, 36, and the 2 is clockwise, so the UDL is clockwise, so minus 2 times 36, and that's the area under the UDL. Now we just need the center of the UDL, so 36 divided by 2 was 18. When you do the math, you'll see the moment at A is actually equal to 0. Keeping in mind that we just got a 0 moment at A because of this particular combination of forces and distances. However, because it is a fixed support, normally there will be a moment at A, for a support moment at A. But because we had the proper combination of supports and distances and forces, we got a moment at A. So that's kind of tricky, so you got to watch out for that. So now we know that we start at A, got a maximum, and then we know that because our internal hinge has 0 moment, our picture, our diagram is going to look like this. So that's positive. Positive moment from A to B. So now we need to look at drawing our diagram from B to C. And similar, we can take another section, sum our moments, and we know that there's going to be, our equation is going to be 1 degree higher than our shear force diagram equation, which was just a straight line. So it's going to be similar to this. It's going to be another parabola. So what we would need to do, let's calculate our moment at point C. By doing that, all we need to do is calculate the area under the curve of our shear force diagram. So if you look back to the original picture, minus 12 times 12 plus minus 36 times 12 divided by 2, because it is a triangle, and that will give us negative 288 kip feet. So that is going to be our maximum moment, and you can see that it is negative, so our max negative moment of negative 288 at point C. We know that is going to follow, that's a bad picture, it's going to follow, it's not going to be a straight line, so to note that this is not a straight line. So keep that in mind. And then we know that at point D, our moment will be 0, so we can just connect up. And if you like my videos, share and subscribe. Also check out my website at www.everythingeng.com.